Hello InfoPerson, this is Anton, and today we're going to be discussing some really interesting discoveries in regards to ridiculously massive black holes. And in this case, sleeping black holes located almost at the edge of the observable universe. And that's because for the first time ever, scientists using the James Webb Space Telescope were actually able to directly measure the mass and a lot of other properties of an extremely distant black hole, even though it's technically dormant. It's basically not producing any light and any emissions. And though by itself this is already quite a large milestone, here it gets even more surprising when we actually discuss the mass that they discovered and what this black hole seems to have done to its galaxy and to its surroundings. And so in this video, let's discuss some of the discoveries in a little bit more detail. But to understand why this is such a big deal, we first need to take a look at how we usually find these objects and how this specific discovery sort of changes our understanding of the early universe once again. But also, let's actually just start with where and how this was discovered. The black hole in question resides at the heart of a galaxy referred to as MRG M0138. A galaxy in a region that became very famous for being a kind of a supernova factory, but also for containing this beautiful gravitational lens. And so because this is a gravitational lens, a lot of light that comes from very far away distances sometimes takes multiple paths and becomes visible several times. In other words, we see multiple copies of the same event, including the same galaxy, several times at once, but in slightly different timelines. And obviously, when there is some kind of an explosion such as a supernova, we also see this explosion several times, very often separated by several years. And that's actually why this particular region was so exciting a few years back. That's exactly what scientists discovered here when they identified multiple lens supernova. Here they even received the nickname Requiem and Encore. But even more intriguingly, based on current calculations, researchers now expect the third appearance sometimes in 2035, which is why this particular region has been actively studied and actively observed for several years. And basically that's because it has this natural magnifying glass created by the gravitational lensing effect, a result of this very massive cluster of galaxies sitting directly between us and MRG M0138. And the gravity from this cluster is so ridiculously strong that it directly magnifies light coming from that background galaxy, making it appear at least 30 times larger and 30 times brighter than it actually is. Which is essentially what scientists wanted to investigate once again, but this time by using the James Webb Space Telescope, and of course by observing this in the infrared. And specifically, they were actually able to observe what's known as the sphere of influence around the central black hole, the region where the gravity is the dominant force, and the region where it actually is possible to measure the stellar velocity with incredible precision. Here's actually a more visual example from our own galaxy, from the Milky Way, and the stellar velocity visible as a result of the Sagittarius A-star black hole producing the gravitational effects. This particular time-lapse took a few years to make. But normally, when scientists study distant black holes, they can only do so by studying different active black holes, such as, for example, quasars or different types of AGNs, or essentially black holes that are active and produce all kinds of emissions as a result of the accretion disk and various jets interacting with the surroundings. And so normally we find these distant massive black holes when they're active and when they start to glow super bright, even brighter than the entire galaxy, as they start to consume a lot of matter. Yet in this case, this is practically the opposite. This is a dormant black hole, just like Sagittarius A-star, and it doesn't seem to emit any of its own light, making it nearly invisible to traditional telescopes. In other words, it was only assumed that there is a central black hole in this galaxy, but until this point, its actual presence was almost impossible to prove. And so how exactly did researchers find this black hole, and more importantly, how did they actually establish its mass? Because apparently, this is an enormous object. It's approximately 6 billion solar masses, which is roughly around 1,500 times larger or more massive than the black hole in the center of the Milky Way. As a matter of fact, here it's sort of comparable to the famous M87 supermassive black hole, because it seems to have a very similar mass and a very similar size. And well, in this case, the team whose study you can find in the description, with researchers from University College London and Carnegie Science, used a technique referred to as stellar dynamics, or basically once again the same method involving tracking the collective motion of stars as they seem to orbit this invisible central point. Except that in this case, instead of looking at Sagittarius A star, which is about 26,000 light-years away from us, they were looking at an object that's about 17 billion light-years away from us at a redshift of 2. And so trying to see such a tiny point from so far away up until this point was practically impossible. And well, that's because we're really only talking about a region of just a few light-years across, which from such a ridiculous distance would appear extremely tiny. As a matter of fact, here it would appear almost completely invisible, and under a standard geometric view would appear as something like 4 times 10 to the power of -5 arcseconds, or kind of like looking at a typical quarter from something like 80,000 miles or 130,000 kilometers away, or about a third of the way to the moon. And so normally this technique is only used for nearby galaxies, not galaxies at such ridiculous distances. As a matter of fact, at the moment this is at least 15 times farther than the previous record of its kind. But thanks to these gravitational lensing effects, it was possible after all. And so even though at this distance, even the James Webb is not able to see individual star motion, the gravitational lensing effects provided enough data to observe motion of multiple stars, or basically groups of stars as they move around the black hole. And so this extreme magnification allowed researchers to observe the speeds and orbits of this distant galaxy's stars and allowed them to calculate the exact gravitational pull, revealing that the black hole is 6 billion solar masses, but also proving that tracking stellar motion through gravitational lensing seems to be a viable method for studying the distant universe and for trying to measure the masses of these distant black holes. As a matter of fact, using this, scientists can now figure out how many of these ancient black holes developed in the first few billions of years of the universe. But here there is obviously one question. This black hole is very massive and also very young, so why exactly is it so quiet? In other words, why is this not a brilliant bright active galactic nucleus resembling a typical bright quasar or a blazar? In other words, why exactly is it dormant? Well, right now, based on some of the additional observations, scientists speculate that it probably was very bright a long time ago, with the galaxy hosting an extremely active and very bright quasar, but it potentially grew so fast that its intense energy expelled all of the galaxy's gas away from it, preventing the galaxy from forming new stars and also preventing the gas from feeding the black hole anymore, with this process abruptly shutting down the star formation, or basically killing the galaxy, but also starving the black hole of its own fuel and leaving the entire system completely silent. This is actually something that's been observed in a lot of other systems, but usually much closer, and well, in this case we have something very far away, existing about 10 billion years ago, and essentially showing us that first of all, these extremely massive black holes seem to have already existed back then, and second of all, some of them potentially killed their galaxies very early, quenching the entire region and silencing everything in the vicinity. And so right now, based on the observations, it looks like the reason this region looks so calm and so inactive is really because of the activity from this massive black hole that seems to have stopped abruptly not so long ago. And it's the black hole that eventually starved the galaxy and itself. But this of course raises that next question of how is such a giant even possible so early on? Or basically, how did this black hole get so big so fast? And that's of course the question astronomers have been trying to answer for the past few years, especially because the James Webb Space Telescope discovered so many of these black holes. But the question we cannot answer yet. As a matter of fact, at least one other study, based on something even more far away, definitively shows a very similar trend where black holes seem to completely outgrow their own galaxies, and in some cases black holes become so massive that the galaxy seems to never be able to catch up, basically suggesting that it's really the black holes, at least in the first few billions of years, that seem to dominate everything and seem to control the growth of galaxies. And that's not at all what we see in the local universe, with local galaxies mostly being dominated by gas and dark matter. And so finding so many different black holes at such distances, with so many of them exhibiting very similar properties, essentially confirms that the early universe was a lot more mysterious and a lot more unusual than astronomers believed a few years back. And mostly because we previously could only see these very bright active black holes, or basically quasars, which actually seems to be just a very brief part of a typical life cycle of a black hole. The majority potentially stay dormant and are thus a little bit more difficult to study. And so by finding these quiet ones, we can better understand how black holes develop over billions of years, and more importantly, how they fundamentally shape the evolution of galaxies and the universe itself. Although when it comes to this study, the biggest takeaway is really this new technique for how to measure the mass of a very distant, very massive black hole. A 6 billion solar mass black hole inside MRG M0138. All the chances are we might be actually seeing even more of these once telescopes like Euclid and the Nancy Grace Roman Space Telescope start to uncover even more of these lensed events and allow us to see even further into the depth of the universe. Anyway, on that note, we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access and a few more things. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.